Now that we know how to evaluate logarithms, our next step is going to be how to graph them, how to graph logarithmic equations. And it can be shown that a logarithm is the inverse of an exponential equation. That's something I'm not going to go into in this video, but it is worth seeing, especially if you're going on to pre-calculus. So you could probably find another video online or ask me about it in class and we can talk about it. But because it's the inverse of an exponential graph has a horizontal asymptote. What this means is that our logarithm graphs will have vertical asymptotes. So I have some rules right here, and I didn't really do a good job justifying them. Like, I didn't give you math proof of why these work. You'll see through example that they do. So there's going to be a vertical asymptote at x equals 0. The points 1, 0, and whatever your base is, 1, are going to be on the graph. And we're going to use those 2 points to make our graph. And if there's an a value, what we're going to do is multiply our y coordinates by the a value. Let's try out a couple examples, and then we can you'll see how this plays out. So, I didn't, oh well, I messed up my graph here, sorry. I didn't give a good justification of why there is a vertical asymptote. You're just going to have to trust me on that for now. Ask me about it in class if you're not sure. But we're going to have a vertical asymptote at 0 here. So instead of having a horizontal tail like we did when we had exponential graphs, because this is the inverse of an exponential, we are going to have a vertical asymptotes. So to figure out the points that would have gone on our graph, I gave you rules, but I don't want you to memorize the rules here. I want you to actually think about logs. So I put my equals y on this side because it'll be more familiar to you guys. If y was 0, 4 to the 0 power is going to get us 1. Anything to the 0 power equals 1. So x would be 1, y would be 0. The point 1, 0 is on the graph. So that should make sense. You can kind of see that works through the example there. And if y was a 1 here, 4 to the first power would get us 4. So if we had a 4 in for x there, we would get out a 1. So base is 1, 0, base, 1 are our 2 points. So I have 1, 2, 3, 4, 1. Those are my 2 points here. And now what I'm going to do, my tail, I kind of follow the flow of my points here like I did with exponentials. My graph is going to look something like that. Logarithmic graphs do not grow very fast at all. It just kind of goes like this. It's the inverse of an exponential. Our domain in this problem, the x's that we use, go from this line onwards here. We're looking at x is greater than 0, and our range is all real numbers. On my second example here, if I plugged in a 0 for y, I would get out a 1 for x. So 1, 0 is on the graph. And if I plugged in a 1 for y, 2 to the first would get me a 2, so I have base 2, 1. Asymptote is still at 0 here, so I'm looking at a graph that would look something like this. Domain x greater than 0, range all real numbers. Going down and it's going upwards. On my last one here, it's a little bit trickier in the sense that we have an a, or a number we're multiplying by out front. Now, my points that I was going to use would have been 1, 0, that's a given on a log graph, and base, 1. This is what we would have been working with here. However, we're going to multiply whatever we were going to get by 4 to get our y. So what we need to do is multiply just our y coordinates by 4. You're going to do whatever you want with x, plug in a number, but whatever number you would have gotten out for y is getting multiplied by 4. So 1, 0 is still going to be 1, 0, because 0, 4 is still just 0. But 3, 1, you got to multiply the y. We were going to get out a 1. We're going to get out a 4 now, because 4 times 1 is 4. So my second point here would be at 3, 4. And once I have those 2 points, let me see if I can fit this in here. My graph is going to look something like that. That's not a very well-drawn graph there, but it kind of stretches out the graph and makes it grow a little faster. So my domain, x greater than 0, my range is all real numbers.